Hello, my name is CARSTEN, and today I will be explaining biomechanics and the different subcategories which fit into it. In this video, I will be explaining the different types of motions, what is meant by scalar and vector, and the difference between weight and mass. Firstly, we are going to look at biomechanics as a whole. As you can see, the definition is the detailed analysis of sports movements in order to minimize the risk of injury and improve sports performance. It's basically just how the body moves. Here it shows that you can break down biomechanics into two different categories. The first category is kinematics. Kinematics is the branch of mechanics concerned with the motion of objects without reference to the forces which cause the motion. It's the description of motion with no regards to what is causing it. Basic quantities of kinematics are distance, velocity, acceleration, and momentum. An example of kinematics in sports is during the golf swing. Kinematics focuses on details of the swing motion, such as the shape of the club head path, positions of the body in the club, and the velocities of the body in the club. The other category of biomechanics is kinetics. Kinetics is the study of forces that are acting on an object under a particular mechanism. It focuses on the cause of the motion. The basic quantities of kinetics are forces, gravity, and friction. During the golf swing, there are largely two different forces acting on the club: gravity and the weight of the club, and also the grip force exerted by the performer's hands. Since the weight of the club remains the same during the swing, the grip force is the primary factor that influences the club's linear motion. Linear motion is important in sports. It is basically when an object moves in a straight line, such as a sprinter running on a straight track. Pure linear motion is the movement of an object or system moving in a straight line, moving as a unit with its different parts or limbs not moving. However, it is rather uncommon in sports that you see this. For example, even when a sprinter is running in a straight line, their limbs are moving in various directions to produce the movement. There are two types of linear motion: rectilinear motion and curvilinear motion. Rectilinear motion is motion along a straight line of path. Curvilinear motion is motion that occurs along a curved line or path. In some sports, such as a 200-meter sprint, rectilinear motion and curvilinear motion can be used together, as the athlete starts from the blocks on the curve of the track and then runs a straight line finish. Linear motion can be split into two different quantities. Scalar quantities can be described as a physical quantity that only has one size. For example, distance is a single value between 2 points, such as a football being thrown 50 meters. Mass is a single measure of how much matters in an object. For example, an athlete could weigh 90 kilograms. Another example of a scalar quantity is speed. For example, a sprinter can run 10 meters per second. The reason these are all scalar quantities is because they do not have a direction and only have a magnitude. A vector quantity can be described as a physical quantity that has both size and direction. We now have displacement, which is the shortest distance between start and finish. For example, a rugby player might run a distance of 25 meters in order to get around the defenders. However, their displacement might only be 12 meters because that is the distance between the start and the finish point. Weight is also a vector quantity because it's the force exerted on an object or person by the gravitational pull of the Earth. This means that there are two different factors in order to find out the weight of something: mass and gravity. If the gravity is different on two different planets, despite the mass of something stay the same, the weight will therefore be changed. Generally, with vector quantities, if one factor is changed, then the quantity as a whole will be changed. We are going to look at mass in more detail. Mass is the quantity of matter that makes up an object or person. It tends to depend on the density and volume of an object and is measured in kilograms. It's a scalar quantity because it only has a magnitude. Generally, the mass of an object stays the same. However, the mass of a person is likely to change. For example, if an NBA player decided to bulk up, the density of their body would increase, and therefore the mass would too. Another example is with a golf ball and a tennis ball. A golf ball might have a smaller volume and a larger density than a tennis ball, but despite the tennis ball being larger, the golf ball has a higher mass because it has a higher quantity of matter inside of it. The mass of an athlete can affect their performance. For example, a long distance runner should have less mass because it will allow them to run longer distances whilst carrying less mass. However, if a 100-meter sprinter tried to run a long distance, then they would struggle because they have a higher mass. Weight is different to mass in that it is a vector quantity. Weight is a force exerted on an object or person by the gravitational pull of the Earth. The reason weight is a vector quantity is because its direction of force is always towards the center of the Earth. On Earth, the gravitational pull is constantly 9.81 meters per second per second. Weight is measured in newtons. It is common that weight is measured in kilograms, however, this is not correct. Only mass is measured in kilograms. The equation for weight is mass times acceleration of gravity. This means that 1 kilogram on Earth equals 9.81 newtons. Another example is 60 kilograms times 9.81 meters per second equals 588.9 newtons. This is because the gravitational pull is different on the moon. Someone who had a mass of 60 kilograms would have a weight of around 100 newtons on the moon. Thank you for watching my video.